Hi, everyone. Thanks for joining us today. My name is Melissa Schilling. I'm the Herzog Professor of Management and Innovation at NYU Stern's Management and Organizations Department. And I am excited today to have Natalia Levina, the Paganelli-Bull Professor in NYU Stern's Technology, Operations, and Statistics Department, here to talk about her research on the adoption of artificial intelligence in organizations. So welcome, Natalia.
Thank you, Melissa. It's my pleasure to talk to you about this topic.
Awesome. So why don't you just start us off by telling us a little bit about what your research on AI is focused on?
Sure. So over the last few years, I've studied diverse aspects of how AI gets adopted in organizations. One of the studies that I have completed with my former PhD student, Sarah Lebovitz, and my colleague, Hilal Ifshitsazaf, focus on the evaluation and adoption of AI in diagnostic radiology, like a hot topic around AI. Another recent study I have done is with a colleague, Elmira Vandenbroek, at the Stockholm School of Economics, and that one focuses on the use of AI for hiring, so in human resource management, another one of those biggest for AI use. And currently, I'm investigating, of course, like many people focused on generative AI, I'm interested in how organizations set policies for the adoption of generative AI like ChatGPT.
There's so much to talk about here, but a lot of us have probably seen these very provocative articles on how AI can actually be more accurate than humans in radiology for maybe spotting a cancer or something like that. Is that consistent with what you guys find in your research?
That's a great question, and I have a kind of simple answer to it at first, which is these claims are largely overstated. So when we have really investigated this phenomena in depth and looked at the real doctors in the real hospital, and it's a cutting-edge hospital in terms of quality of care using these tools, we found that these claims are actually quite overstated. And in particular, if you think about these claims, to say that a human is better than AI or an AI is better than human on any particular task, we have to agree on what a correct measure of that performance is, like what is correct and what's erroneous. And that's at the heart of these claims, right? And so when we looked at these tools, machine learning developers, they develop these tools based on the data set called ground truth data set, which is used where the images, for example, are labeled as having cancer, say not having cancer, or for some other diagnosis. And this data set is used to train and evaluate the tool. And what's important is that if you start digging under the hood of what actually goes into this ground truth data sets, a lot of the times in diagnostic radiology, this is aggregated opinions of several physicians on a given image, on a single image. But in practice, what the doctors use to actually make the diagnosis is very rarely a single image. It's very often multiple images and on a given patient, prior images, clinical data. So if you start looking as to what AI said, what the doctor said, shouldn't be that surprising then that the doctor is saying different things from the AI because they're drawing on a different set of information. And when you just compare them by asking doctors to make the diagnosis based on single image, it's not really the right comparison. So what we found is when the super high performance tools, according to machine learning vendors, were not performing very well in actual clinical practice, it was often that the doctors actually were drawing on broader data, basically, or using some of their tested knowledge to make these decisions. And as a result, we did not see much support that the tools were performing at this amazing accuracy rates that they were claimed to have been performing.
Wow.
Yeah.
That really highlights the complexity of it, right? Because they're basing their assessments on a different pool of data, essentially. And then does it also limit the, if a doctor misses, if the pool of doctors miss something that's actually a cancer indicator in the image, is that training the AI to also miss it?
Exactly. That's the second point. Thanks for reminding me. On top of this issue of the ground truth just being disaggregated, there are many areas of medicine where the knowledge is actually uncertain. And as a result, having a bunch of doctors agree on something doesn't make it truth. So some of these cases that we studied that are more complex, what we often found is that doctors in our study actually saying, we don't know who is right. We don't know if AI is right, if those 5 doctors who looked at that prior image were right, or if we're right. simply because the level of knowledge in certain areas of medicine is uncertain. So you cannot know what the truth is.
Yeah.
Just also to give you an example, sometimes we may learn the truth years later, like for cancer diagnosis.
Right.
And very, very areas in our current healthcare, we trace this data like from early imaging all the way to many year follow-up. And even when we do, like if you think about ideal training data, it would include biopsies, for example, on healthy people, and we don't want to do that. So that's where the problem is, like real high quality ground truth is extremely hard to obtain.
Yeah.
And that we make these claims that something is like AI is super accurate based on this limited ground truth. So
Yeah.
I'd be very cautious about this kind of ground truth quality and this all claims that are being made based on it.
Yeah.
Now,
Ground truth isn't even the right word for it, really, right?
it's data.
Data. Just data, collective opinions,
Yeah.
All right.
Just to be clear, there are some areas where I see sort of what I would term extremely high quality data being used to train AI, and then we should consider these tools more seriously. So I'm not all like negative, throw them all away. I just think we need, my research shows the bar should be much higher than what it is right now.
Cool. Awesome. Well, I know that you and your co-authors looked at actual ways in which doctors use AI in their daily work, about where the human interacts with the AI in that loop. What did you learn about this integration of humans and AI, or what I think you call a human AI augmentation model?
That's right. We did look at the specific uses, and back when we started the study in 2018, 2019, it was actually hard to find like full-blown implementations of AI in professional practice. Now there is a few more. And what we learned was actually, first of all, like people nowadays, as AI is becoming more widely adopted, thinks that putting human back in a loop is a silver bullet solution to limitations of AI. Like you like have a tool that may be biased or not fully accurate on marginal cases. You just put human back in and you fixed all the problems. So that turns out to be, again, a much more complex process. Just putting human in a loop doesn't solve all the problems. But we were able to understand this process of human AI augmentation in a bit of detail. So first of all, in the area of diagnostic radiology, by law, AI tools are supposed to be used as second opinion tools. So it's not really the case for all types of human AI augmentation, right? So I'm not going to say we learned everything about human AI augmentation. In the case of diagnostic radiology, the way it's supposed to be used is human makes initial assessment first, then opens the tool and considers the tool's opinion and tries to reconcile. And it's actually, I think, a good practice, right? That's kind of what you would like. You would like the doctor to first take a look and make their own opinion. So in that particular case of second opinion used for decisions, right, what you should immediately notice is, given that process, the use of AI takes more time than not using it, right? So if you were able to make a decision by yourself in time X, having a tool added to your consideration and you needing to think about it is going to increase that time. Like I think simple example could be like we nowadays use a lot of tools for checking grammar in our research papers, right? And students use it. Like if you think about like the best you can do by yourself, then you have your paper, but then you go to Grammarly or ChatGPT and it gives you a ton of suggestions of how to further improve grammar. You might actually achieve higher quality, but it's going to take you a lot of time to get through all these suggestions, right? That's the same idea because Grammarly or ChatGPT or other grammar tools are basically second opinion on your paper. So with that kind of image in mind, think about what happens in healthcare. You have a lot of work to do under a lot of time pressure. And now you ask to consider a second opinion from technology on a whole bunch of cases. So of course you need more time. And what we found is that the business case for AI adoption is often made on cost and time saving rather than on quality, but it should be made on quality, right? Because the only way you're going to get there is by spending more time. Now, if you are not really increasing significantly the time for the doctor to consider the second opinion, what's going to happen is they are very likely to adopt in potentially what we would term non-engaged or perfunctory way, right? If they don't have time to consider what they are saying, they might like either agree or disagree. In our case, without further consideration. So in our case, the doctors were very high quality professionals. So they tended to basically ignore AI's opinion if they didn't have time to get into it for tools that they deem to be not super helpful given the time pressure. Because if you think about it, the opportunity cost of the time is high. It might be better to ask a colleague or to ask a student or to run another test, right? If you're spending that extra time. Just to give you a specific, like on average in published studies in mammography, to look at a single breast cancer mammography, doctors are allowed about 75 seconds per case. So it's really like a minute plus. And incorporating AI adds another 6 seconds if you're doing it. So think about how much you're going to get out of it in 6 extra seconds. And on top of it, the tools are very opaque, right? You don't know why they're saying what they're saying. So before I move to the black boxing part of the tools, I just want to say that if you look at human AI augmentation with a human in the second opinion type of case that I just described, you have to think about making a business case based on quality or longer term cost savings. So if you prevent an error, so long term, you might recoup the costs, right? But moving on to this black box issue, in general, like we know new machine learning tools are often opaque to humans, but even without them being like the new generation neural nets being opaque, in general, people may not have time or resources to understand why technology says what it says. Even if in theory, somebody could get the full explanation, in practice, if you have 2 minutes to consider a case, you just don't have time to dig into it. Or in case of newer technology, we looked at brand new tools, people just don't quite know how to configure it to understand why it says what it says. And if you are in this case and you have a high stakes decision to make and you don't know why the tool says what it says, you can't make sense out of it, any reasonable professional will either, will ignore it, because you just can't make sense out of it. So the only other choice we saw is when people were confused as to why AI says what it says, they just took extra time themselves to take a second look. So it's not like AI really helped, but it made them pause. So that's like this case of where you have to think about AI tools being black boxed in practice, not just in theory, right? In practice, even the tools that could be explained, you have to let people have the time to figure out why it says what it says. On the good news is we saw one case in our study, and in this case, it's lung nodule detection with CT scan, where the doctors actually figured out how to make sense out of AI's output. And in this case, they developed what we would call, practices to interrogate AI results. So that doesn't mean they really open the black box. The tool stayed black box, but they could use other parts of their technological environment, like rotate an image, zoom in, to figure out whatever the tool indicated was real or not quite quickly. And as a result, they started seeing this tool as what they call mission critical. Like if the tool was down, they would just not read, they would delay the case and say, we're waiting for the tool to be available. So what's the bottom line here? Is that if you are actually using, introducing this type of tools in this human in a loop and the human and AI kind of both experts, you need to give people the time to develop this investigation practices to interrogate AI, as well as sort of time to spend more time per case, like we just discussed, so that eventually you make the business case based on quality or long-term cost savings. So that's kind of part of what, I think we've the most important parts of our study I'd like to highlight in this case.
So that's a really important insight. Would you say that generalizes to other areas of healthcare or even maybe beyond healthcare?
Absolutely. I think that observation generalizes to any. So I would say from what I see now, it would be a case where AI and humans are both making a decision, right? So I don't know. I have different thoughts about generative AI and creativity. I think that's not maybe the same, but when it's a classification type of decision and the AI is used as a second opinion expert, which is similar to what we see in human resource management as well. Maybe human looked and then AI says, I think it's a great candidate or not. etc. I think, and like I said, for Grammarly, like in a sense, is this a well-written sentence? Yes and no. So I think it's a great sentence. I love my words when I write some of the sentences, and then Grammarly says it's too long, it's too obscure. Like, so that's the same case. So the same ideas would generalize. It's going to take more time, but in that reconciliation, if I have time and I start trusting the tool, I would end up with higher quality than if I didn't, especially if my own capabilities are not perfect, which they rarely are for professionals in any area. You always have some mistakes.
This is so interesting because I think a lot of people assume that AI would be used to speed things up. And what you're highlighting is that it's actually going to take longer, but it's going to give us higher quality results. What about?
Sorry, just Melissa, to interrupt, just to be clear, there are cases of full automation, like humans out of the loop. To be clear, I think this is gonna, if that works, and that's a big if with high stakes decision like medicine, and like I said, then you go for an amazing quality ground truth. But in those cases, I think it could be an efficiency tool. So just an augmentation part of this type, I think it's not an efficiency tool, it's a quality tool.
Okay. And did you guys speculate on any implications for policy, like policymakers?
I would say we for sure we did. Before I even get to policy, I was just going to mention just in terms of managers, because we can wait for policymakers to make policy. But I think that for managers actually managing it, I think just quickly, I think what happens is that they underestimate some of the costs, like that I just mentioned, and some of the risks as well. So I'd say, broadly speaking, managers need to consider these changes in processes and make very different cases and assess the risk of potentially limited data quality or ground truths. Because like I said, it doesn't necessarily always mean don't use the tool, but it means that you better understand what you're using and why. Now, similarly, if you go to policymakers, because I think in some sense, policymakers are like mega managers, right? They're gonna set the tone for the rest of organizations. In our case, it would be FDA. I would say, again, the clear takeaway is higher rigor data sets, like higher standards for ground truth should be used. Because I feel from what I've seen, and we did look at a bunch of FDA filings for diagnostic radiology tools, the current sort of things that seems to satisfy them is like aggregated opinion of a bunch of radiologists, and sometimes not even radiologists, like a surgeon as well could be used, or not even fully trained radiologist on a single image. What they should do is to look at the actual professional practice of physicians to see what's actually goes into the decision, and either try to incorporate parts of that into the requirement for the tool, or because of course AI is not going to make decision the same way as humans. So if you don't do that, then go for extremely high quality ground truth if you can. So for example, just to give you an example, I've seen a case of a tool being developed in Europe for Alzheimer and dementia detection. And there, by the way, doctors, radiologists are really bad currently. So you could argue like nobody was even thinking about aggregated opinions, because everybody knows that radiologists, this kind of disease is very hard to diagnose. So what the Alzheimer Foundation is developing, like a multi-year, I think at this point, 5 years already collected of data with psychological testing, like that's high quality ground truth, where you have both images and long-term data of different types. So if one day we have the data all cleaned and ready, I would say go for that tool, because I'd say this is high quality data to develop such a tool from.
Did these tools have to go through clinical trials?
It's type of, yes. Basically, they have similar type of things, not exactly same as pharmaceutical. And by the way, that's my second takeaway for policymakers. I think what we currently do for drugs is quite different than what we currently do for the tools. For this tool. So first of all, like the responsibility when you put in the drug on our market, and if it ends up hurting somebody, still with a pharmaceutical company, right? Only partially it is with a physician and the healthcare. With the AI tools, it's completely on healthcare organizations and physicians. So once it's cleared, it's like really the tool maker is done with responsibility. And the adoption costs are also all on healthcare organizations and doctors. Whereas again, if you look at pharmaceuticals, they spend a ton of money to help you adopt, right? Like on every level. So I think it's useful to think about these AI tools as in a similar way, maybe not all the way like we do pharmaceuticals, but where there is some shared responsibility, a much higher bar. So clinical trials is that, but they're not like sort of same level of response requirements that we see in pharmaceuticals.
Cool. So I know you really focused on these machine learning tools that were built specifically for radiology, but do these insights generalize to the new generation of AI we're seeing, like models like ChatGPT?
Yeah, it's like a great question. You're addressing an elephant in the room. Like I'm talking about this almost like when we did this research was latest and greatest, like since December 2022. Like why are we not talking about ChatGPT when we're talking about AI? So I gave it some thought. I haven't studied it. My thought is that when you talk about generative AI, where AI is used to generate stuff rather than to assess stuff, right? Make a decision and classify. I do think that augmentation is quite different, right? Like AI often goes first, right? I ask ChatGPT to write a poem for like my friend's birthday, and then I don't first write, right? I ask the ChatGPT to go first, and then I go free. I do a few iterations, I put things together. So I do think that potentially there is an efficiency case, and I have seen in the industry, especially in creative industries. Clearly it's an efficiency tool, not just a quality tool. Right, so people start to generate content. So I wouldn't say that part of our insights generalizes. It's all about quality, not efficiency. I would say, on the other hand, when you use ChatGPT for grammar check, right, or improving your writings that you already have done, it's actually very similar, right? Because it's just like what I described. And similarly, when you think about using ChatGPT for analysis of data, right? You still have to check, right? So if you still have to check, and you also are as much of an expert, if not more than an expert, and this is a key part, I think, of what we find, the full responsibility for quality is on your shoulders. So, right, so if you submit a paper at the end of the day, you can say, oh, ChatGPT made poor choice, right? Its responsibilities on you. You may very much end up having this kind of like quality cost trade-off where you might be spending more time for higher quality. So my sense is for this type of tasks that are similar, classification, decision, high stakes, full responsibility on you, I think the findings will generalize. For some other tasks we use ChatGPT and generative tools for, it's going to be quite different.
Wow, this is super fascinating. So why don't you take a moment just to tell us on what's next? What are you working on now?
Yeah, so I mentioned that one of my current projects is on the AI implementation for hiring, a topic that's more clear to most of the people listening to this than probably radiology diagnosis, right? Like
super hot area, yeah.
Yeah, I also like when I teach and I talk to people, so many people now have gone through something like AI pre-test for their interviews. Like oftentimes it's like an IQ, EQ type of test, like a whole bunch of cognitive puzzles and how quickly you do them and what you pay attention to and so on, and like assessment of some sort of reactions to situations. So that's AI, basically what they call neuroscience type of AI, used for screening for HR. And that's a kind of tools that we studied with Elmira van der Broek. And it was a large multinational corporation. And it was, the interesting part is that these tools were not seen initially as efficiency tools. They were seen as way of dealing with biases, right? Because you're thinking, having humans who would, basically reproduce the societal biases. If we have people take this test, right, these tests look like unbiased, objective to a degree at least. And they were also seen as improvement in quality because this was used initially, at least the tool was developed for their management trainee program, where they ended up often having like people who didn't fit very well based on the typical recruitment practices. So they thought maybe this is a benefit. So that particular study is actually focused on the question of where the data comes from. So if you remember, I mentioned competence at ground truth is like, think about HR applications. If you very often the tools people develop are based on recruiters' outcomes. So you take historical data from resumes and applications, and you try to build a machine learning tool based on who got through, right? How many people got to be called for an interview, for second interview, and eventually hired. first of all, you immediately see that such data would reproduce the biases that you try to avoid. So of course, this company realized that. And so it's in the machine learning tool developers were saying, we need different data, right? If we want to overcome this, what kind of data do we really want? Again, think about ideal ground rules would be performance data, right? Or evaluation data from an interview at the very least. But if you want to produce this type of data, right, what do you need in theory is have a large set of employees with uniform performance evaluations, so comparable, right, across a bunch of people.
That's asking a lot.
And top of it, all of these people should be taking those EQ tests. So your current employees should be then taking those EQ tests while working for you. And so what we saw, of course, is a lot of backlash. People felt they were pushed like to submit this when they were already in a company. What if they get exposed? Like, you know, ask me to do it. What if my IQ is not high enough to work at Stern, right? Like, oh my God, oh, my EQ is not high enough, right? And suddenly I'm put through this. And you need it from low performing people too. And people are told, and there is law saying, it's not going to be used for evaluation, don't worry. But of course, once you have it, as always with data, for example, it starts being used for a career planning. Well, sounds like it's supposedly benefit to you, but if you want to go into next step for marketing and your IQ says you should be doing IT, maybe that's not how you want to be doing career planning. So the bottom line from this research is that in pursuit of data for the super hot AI kind of tools, you may end up transforming organizations in a way you haven't thought about, because people tend to think about societal biases, ethical issues, and so on when implementing the systems. What happens here is a huge cost to organizational culture. Everything that was informal becomes more formal. Different performance measures across very different types of jobs become more uniform. The other things that happens is you want everything recorded in like forums as opposed to discussions. So hiring managers were asked to stop talking to each other and like click a bunch of buttons and like record everything and rate, because that's what the tool can learn from. And to me, like one of the most interesting takeaways from this is, even if you pull the plug on this tool and said, forget it, it's low quality, we're never putting it in place, your organization has already changed. So even without implementing any AI that this was built for whatever reason, you might decide it's not good or suddenly AI is not hot anymore. You already transformed your organization in tremendous ways without giving it much thought. So that's my current project.
Wow. Well, that sounds really, really cool. And we'll be excited to see it come out. I think anyone who's watching this can already tell that your IQ and EQ are off the charts. and we are so thankful to you for coming and spending some time with us today, Natalia.
Well, thank you, Melissa. As you see, I'm very passionate about this stuff. I could talk about it for a long time. If people want to reach out, I'm very much open to talking to people about this stuff. They could reach me via my email.
Oh yeah, we're going to drop that email address into the description of the webinar, so you can find it there, and feel free to tweet about this webinar on Twitter or on LinkedIn. And thank you again, Natalia. It's great seeing you.
Good to see you too. Bye.